Hi guys, today we're going to have a look at using SOLIDWORKS simulation in the online trial version of the software that you can see I've got open in front of me. The first thing I'm going to do is open a model from my recent files list. There's a whole load of example content on here. The one I've chosen is the complex machine part, but any number of these assemblies or parts would be appropriate for a SOLIDWORKS simulation. Okay, so the first thing we're going to need to do is to turn on the simulation add-in. This can be done by going to Tools and Add-ins, and you just tick the simulation tick box on the left hand side and press OK. What you should notice is that the simulation and the analysis preparation tabs are triggered by this action. So to start a simulation, we go to the Simulation tab on the Command Manager and choose Study. There are a number of ways we could use simulation to test our part, but the test we are going to do here is referred to as a static analysis. One of the main things this means is that any loading, so forces, pressures and that kind of thing, are applied slowly. Quick changes of force like explosions, crashing, quick impact can't be analysed using a static study. I'm going to call the study Force and Tension and give it a tick. You will see that the study appears in the tab at the bottom of the screen and has a tree similar to SOLIDWORKS on the left. First thing we will do in the tree is to give the part a material. We can do this by right clicking the part name in the tree and choosing Apply Edit Material. This will take us to the material library where we can select a material of our choice. In this example, we will use alloy steel. Next, we need to simulate how this part will be held in position. We can do this via the Fixtures option on the simulation tree. In this case, we will say that the rear holes of the part are being held in position by what we call a fixed constraint. This means that there is no movement, either in translation along X, Y or Z, or in rotation around X, Y or Z. Next, we need to establish the loading on the model. Generally, this is done by the External Loads option in the simulation tree. I'll choose the Force option and select the faces of the two front holes. By default, forces are applied normal to the face, as you can see via the arrows. In this case, that isn't appropriate, so we'll select a direction and use the top plane to define the direction. We'll have a force of 10,000 newtons applied normal to that plane. Last step before we run the simulation is to define the mesh. Generally, this means two things. Have we got enough mesh to define the shape well? And is the mesh fine enough to show changes of stress and displacement? Because we don't know what the stress pot looks like before we run the study, sometimes that means we have to run the study predicting where we need to find a mesh, and then make iterative alterations depending upon the results. I will click the Mesh option in the simulation tree and choose Create Mesh. All we're going to do here is select Mesh Parameters and select Curvature Based Mesh and set the slider to Fine. Changing the mesh slider changes the values in the mesh parameter boxes. This in turn changes the mesh size and the quality of the result we get when we run the study. Last, we can press the Run button on the Command Manager. This initiates the calculation and gives us some results. It will take a few seconds to run through, and we should end up with 3 different results: stress, displacement and strain. Don't be alarmed by the distortion of the part. This is an exaggerated displacement to show the direction of movement. You can see at the top left that this is 14 times the real shape change, and the displacement plot shows the maximum displacement is only 2.5 millimeters. Hopefully that's shown a little about how to use simulation in the online trial version of SOLIDWORKS. You can use these principles on any of the example models inside the trial and watch some of our other videos to get hints and tips to go further. These can be found on My Solid Solutions, which you can get to from any search engine. Thanks for watching.